Hey y'all, today we're going to talk more about quadratic functions, and in this case we're going to talk about a different form of a quadratic function. So far when we've been looking at these quadratic functions, they've been in a certain form. We've had an x squared piece with some number in front. I'm going to call it a. And then we'd have some x piece with some number in front of it. I'll call it b. And then most of the time we have some number that has no x. And so this is called the standard form of a quadratic function, where we have an x squared, an x, and no x. And sometimes one of those pieces is missing, but so far what we've seen is usually that they're all there. What you can see in these problems, and I'll make them bigger, is that they look different. I don't have any x squareds in this, and I'm calling it a quadratic function. For something to be quadratic, we need to have an x squared. So this is what's called the factored form. We talked about factors when we tried to divide out a common factor. Factors are things that multiply to make something else. So I gave an example of, let's say, 8. If I want to think about numbers that multiply to be 8, I can multiply 8 by doing 2 times 4. I can do 1 times 8. These are all factors of 8, numbers that can be multiplied to make 8. And so these are factors of a quadratic function. These are the things that we can multiply. A little more complicated than just 2, 4, 1, or 8 like I have over here, but still the same idea. These are things that I can multiply to make my quadratic function. And so we want to take this factored version and write it the way we've been seeing it the last couple lessons. And we're going to use the skills hopefully we developed last unit with polynomials and multiply. So I'm going to start by multiplying this set of parentheses by this set of parentheses. I multiply everything in this second set of parentheses by x. And this 2 is still going to hang out because I'm not doing anything with it yet. And I'll keep parentheses. So x times x becomes x squared. X times positive 6 becomes plus 6x. Then I'm going to multiply this minus 4 by everything over here. This is the distributive property. Minus 4 times x is minus 4x. Minus 4 times positive 6 is negative 24. If you struggle with positive and negatives, you know what I'm going to tell you. Use Desmos. Now I can put these two things together because they both have just an x to the first power. So I'm allowed to actually combine them. So this becomes x squared plus 2x minus 24. Positive 6x minus 4x, that makes positive 2x. And finally, I can, sorry, that should have an x squared. Finally, I can distribute this 2, so I can multiply everything in here by 2, kind of like I just did up there. 2 times x squared is 2x squared. 2 times 2x is 4x. And 2 times negative 24 is negative 48. This is what our function looks like in its standard form. This was the factored form. We used that to find the standard form, and we could put this into the calculator, and we would have our quadratic function. A parabola. Remember, the graphs of these things are called parabolas. So let me try a couple more. I'll do one more maybe, and you can try one. I'm going to multiply everything in this second parentheses by the first thing in this parentheses. So 3x times x gives me 3x squared. I don't need the parentheses anymore because I don't have anything out in front like I did on this one. 3x times negative 2 is negative 6x. Then I get to do 5 times x, and 5 times negative 2. 5 times x is 5x. Positive 5 times negative 2 is negative 10. And I'm allowed to combine negative 6x and positive 5x because they both have x to the firsts. And negative 6 and positive 5 make negative 1. I'm not going to write the 1. There is my function, my quadratic function, looking like we've been seeing it lately. I'll do one more. I'll do the more challenging one maybe. Over here is like the first one we did. I'll start with the parentheses first. I'll keep the 3 out in front for now. X times x is x squared. X times negative 6 is negative 6x. Then I'm going to multiply both by negative 2. I get negative 2x and positive 12. And then I want to multiply everything by 3. Before I do that, I'm actually going to clean this up and make negative 6x minus 2x. That's negative 8x. So 3 times x squared is 3x squared. 3 times negative 8x is negative 24x. 3 times positive 12 is positive 36. So I want you to give one a try. I want you to pause. I want you to try this one. So please pause the video now, try that one, and then when you press play, I'll have the solution pop up. So hopefully you got this same function, x squared plus 3x minus 10. If you didn't, hopefully you can see your mistake. And if you can't, please raise your hand, call me over, and I'll be happy to help you. So in a previous lesson, we pointed out some characteristics of these quadratic functions, and one of those was a y-intercept. These functions sometimes, but not always, also have x-intercept, places where they cross that horizontal x-axis. So I've gone ahead and I've graphed this function here. And I can see that it crosses the x-axis in 2 spots. I'm going to copy those down, negative 2, 0, and 4, 0. Those are x-intercepts. It's the place where my quadratic function crosses the x-axis. Those x-intercepts can also help us write the factored form of our quadratic. There's other ways to write our factored form of the quadratic. This is one way. This might be the easiest way. So we're going to look first at the x values. That's the first number in each. And I'm going to say x is negative 2 and x equals 4. These x-intercepts are also called a couple different things. They can be called solutions. They can be called zeros, and they can be called roots. For right now, let's focus on calling them x-intercepts and see how we can get the factors so that we can write this like we saw at the beginning of the lesson. I'm going to manipulate these two little equations, x equal negative 2 and x equal 4, so that they everything's on one side. So if I want to make this minus 2 go to the other side of the equation, we move it over there and we change its sign. And so we get x plus 2. And then there's nothing left on the right side, so we say equals 0. On this one, we can move 4 over here. When you move it to the other side, remember, we change its sign. So I get x minus 4, and then on the other side, I have 0. And so it should start to look like I have these things like I had above here, like an x minus 2 and x plus 5. And you might see that these are the factors. So I can rewrite my quadratic equation with these as factors. So I'll put them in parentheses, x plus 2 and x minus 4. And that is my factored version of this quadratic equation. So up top at the beginning, we took our factored version and we changed it into a standard version. And here we go, we're going backwards. Here I've graphed the next one, x squared minus 2x minus 8. and I can see, you can see it shows some points where it crosses, and we can pick those points off. Negative 2, 0, 4, 0. This happens to be the I realize we have to go fix something over here. Because this started negative and our parabola turned down, we need to put a negative at the beginning of this, like a negative 1. You can see that our intercepts are the same here. So we're going to end up with about the same function. I can say x equals negative 2, x equals 4. I'm just picking these numbers here. I move negative 2 to the other side, and I get x plus 2 equals 0. Move 4 to the other side and get x minus 4 equals 0. You change sides, you change signs. And so if it's rewrite this, I get x plus 2 times x minus 4. The difference with these two is that this one started with a minus, and so there needs to be a minus in the front there so that it would make our problem negative, which is what we needed. Sorry if that confused you. If it did, you can always raise your hand and ask me for help, and I can re-explain it. So I wanted to do one more. We have this x squared minus 4x plus 4. You can see it only crosses the x-axis once. So there's my intercept, 2, 0. It's also my vertex. And so I can say that x equals 2. I can move 2 to the other side. When I move it to the other side, it becomes negative this time. And when I write the factored version of this, excuse me, I need to have two factors. And what's unique about this situation where I have when I have one x-intercept, and that x-intercept is also the vertex, I put a squared here because technically there is two of them. So we would call this x minus 2 squared. And if we wanted to, we could write it like this, because when you square something, you multiply it by itself. So we could write it like this. Both ways are fine. And if we were to multiply these two, x minus 2 times x minus 2, we would get the function that we started with. So I want you to give this last one a try. Pause the video. Try this one on your own. Graph it. Find the x-intercepts. Manipulate the equations like that, and then write it in factored form. Pause it, give it a try. It's okay if you make a mistake. Then press play and see the answer. So when I graph it, it looks like this. This is another scenario where we have one x-intercept, that's the vertex, at negative 3, 0. So x is equal to negative 3. Remember, x is the first number in this parentheses. So we can manipulate this to get everything on the same side. I'll move negative 3 over, get x plus 3. There's 0 left on the other side. And we need to have two factors at least, so we can write it as x plus 3 squared, and we're going to put a minus sign in the front because a minus was in the front here. Or we can have it like this, minus x plus 3 times x plus 3. Either way is fine. If you got it wrong, that's totally okay. Hopefully you saw your mistake. If you didn't, please raise your hand and ask me for help. You should do some practice. Ask for help if you need it. Good luck.